Will, do you ever feel like the R's are multiplying? It's like first there was VR and then AR and then MR slid in there somewhere and now there's XR? Like, what's up with all these R's?
Look, man, you can't ask about the R's or else they come get you. Look, okay, so here's what happened. First, in the beginning, there was VR. And then somebody was like, you know what would be better than seeing all this stuff drawn on a black background, like in a dark room? What if we could put it on the real world? And everybody's like, man, that sounds really cool. And then the people who make the marketing conversation started talking to the technical people. And they were like, man, that is really hard. We got to do something in between. Like, look, man, we can't do it yet. Okay, it's really hard. So then the marketing people went back to the drawing board and was like, what if we call it mixed reality? And then that went well for the people that came up with that. And then one thing led to another. And now there's like 35 different R's somehow, even though there's only 26 letters in the alphabet. So
that's right. But the X, if I understand, rules over them all.
It's for extreme, right?
Extreme reality. Dude, I've got enough reality. I've got more reality than I can handle already. But the XR is kind of the catch-all term for like any reality tech at this point, right?
I mean, I worked in VR for 6 years. I've stopped paying attention to the R's at this point. Yeah, like if it's in the real world, it's augmented. If it's in the headset only, it's virtual. And the rest of them, I don't know.
Okay, well now,
yes,
it's time for FOSS-R? No?
We don't need no more R's.
We have open source reality to talk about.
We've got too many R's, Brad. Stop the madness. Welcome to the FOSS Pod. I'm Will.
I'm Brad.
Hey, Brad.
Hello. How are you? How's reality treating you today?
It's pretty good, Brad. Before we get into the topic of this week, I want to make sure we thank our sponsor, Google Open Source. They bring all of the value of open source to Google and all of the resources of Google to open source. You can find out more at opensource.google. Thanks, Google. I'm excited about our topic today because it is near and dear to my heart. And it's the first time we've gotten to talk about open source hardware on this podcast.
Yeah, it's kind of exciting. I mean, I know we've kind of like thrown that platitude around here and there over the last couple episodes of like, hey, open source is for more than software. It can be for hardware and creative works and blah, blah, blah. But like, hey, here we are, a real life example of an open source hardware project that anybody can make themselves at home.
So today we're talking to Bryan Brown, who is one of the maintainers, one of the leaders of the Project North Star project, which is like too many projects for one sentence, but
Project North Star,
which is a team effort to build an open augmented reality headset. This is, augmented reality is when you take computer stuff and you paint it over the real world. So you can have screens and images and 3D objects and things like that appear to be superimposed on the real world when you're wearing a pair of glasses, or theoretically at some point in the future, contact lenses or some sort of brain implant if you want to get real dystopian.
I don't.
No.
If it's okay, I'd rather not.
I mean, look, we get into it a little bit later in the episode, but I've been an early adopter my entire life, and I intend to be the latest of late adopters for brain implant technology.
He had some interesting thoughts on that too, about the merger of technology and biology.
Yeah.
It seems like even though he is out there trying to democratize this kind of AR tech for everybody, maybe don't let it get too close to the flesh.
Yeah. So the thing about this project that's fascinating to me is that it is a thing that when I first heard about 5 or 6 years ago at this point, I said, oh, that's impossible. There's no way this will ever work. Because at the same time as we have a handful of people building a scrappy underdog open source headset, Google and Apple and Facebook and Microsoft are spending literal billions of dollars developing this technology from the ground up. There's two types of hardware to develop, right? There's stuff that you can look at and you're like, okay, I know this piece exists. I know this piece exists. And all the pieces that you need to make the thing go together exist. Drones, for example, were like this 10 or 15 years ago. They just needed to get the microcontrollers to the point that they could run the drones. And then it was relatively straightforward. It was just a software problem, he says in a gross oversimplification. The AR problem was way more complicated and kind of still is, in that we didn't have good ways to measure environments in a 3D way that a computer could understand. We didn't have ways to detect where surfaces were, all of the things that the AR headset has to do with, with zero latency and 60 to 120 times a second. There were multiple, like even the display technology was an unsolved problem until fairly recently. So the idea that, like I said, the scrappy underdogs, the open source upstarts could come in and take off the shelf hardware and assemble it in a novel way and build the handful of things that they need from scratch and then get it manufactured in enough quantity that people can actually build the headsets was kind of shocking. And they're doing it. It's happening right now. So the idea that you can have a 6 degree of freedom headset that can move rotationally and laterally through space, so you can walk around with this headset on and see things move in the world as you would expect, and like track your hand position well enough to detect gestures and movements and things like that and get proper pose estimation. And honestly, just track where the headset is in space, right? Like use the external camera sources and know, hey, this is where I am in 3D space and I've just moved this amount of distance. It's a real accomplishment. So
it really came out of nowhere. The fact that all this technology is not only out there, but is now freely able to be assembled into a working whole. Like the first time that I saw HoloLens at E3 couldn't have been more than like less than 10 years ago, probably.
Like 2012 or 2013, probably.
Right.
Yeah.
And at the time it was buried in the bowels of the Microsoft booth at E3 and they treated it like a piece of top secret military hardware. I mean, it was almost like magic at the time. And now here people are literally building it in their living rooms. So as much as this interview is kind of focused on open source hardware and like a lot of that technology is out there and available to be used now, there is still open source software scaffolding that also exists to interface this project with a computer, right? Like there are open source APIs like OpenXR and then WebXR, which is kind of a web implementation that actually make the hardware work, that provide a common base for different types of hardware to work in a similar manner, right?
Yeah, I think we get into it in the interview a fair amount, but the idea is that there's an open framework that then can interact with other open APIs that you would write software against, or even some of the closed APIs like SteamVR and the Oculus API and stuff like that. So these are just software interfaces for programmers and application developers to implement so that they don't have to know the details of every single piece of hardware that's out there. Like if you write an application for SteamVR, the Oculus API, it doesn't care which Oculus headset you have or which Steam VR compatible headset you have. It just knows, hey, this headset will work in this way, and here's what data I need to pass to it in order to be able to render for the screens that it has and the input controllers it has. And then it just works itself out.
Right. Fun fact, OpenXR comes from the same consortium as OpenGL and
Ooh.
Vulkan, which if you've ever played PC games, you have certainly heard those terms before. Like OpenXR is kind of two headsets, somewhat the way OpenGL and Vulkan are two graphics cards.
I think that's what the group that's putting it together definitely wants to happen. And I think it's a good thing that there are open alternatives to the proprietary closed APIs for people. Building platform-specific software, just like it is with game consoles or with phones, is really expensive. So if you have to build, if you as an application developer have to build something for the Microsoft headset and the HP/Lenovo headset and the Oculus headset and the Open headset, at some point, you're just going to say, look, I'm only going to do the one that has the most market share. I'm not going to fool with the rest of it. And having open standards allows developers, it's good for consumers. It's good for app developers. It's really good for everybody. So hopefully they continue to stick around and continue to gain traction. But that's enough about the background. Let's just get right in the weeds with Bryan and talk about why he started making an AR headset. Bryan, do you want to start off by just telling us a little bit about yourself? Like, what do you do and what kind of stuff are you excited about in terms of open source software? Like, what is your day job and what's your fun job? And do you have multiple jobs even?
Yeah, so I'm Bryan Chris Brown. I am a technical specialist at Looking Glass Factory, and I also am one of the main contributors to Project North Star, which is an open source augmented reality headset that you can 3D print yourself. You can find all of our stuff at docs.projectnorthstar.org. If you want to find me on the internet, you can go to twitter.com/Bryan Chris Brown. That's Bryan with a Y.
That's incredible. Like the idea that we could have an open source AR headset, knowing how hard hardware is and knowing how hard AR is, the fact that you have a team that's built working open source AR hardware is incredible to me.
Yeah, it's been a journey. I think like it went from me like digging around on like IRC forums. So like, the original folks who were doing North Star Leap Motion essentially open sourced it and then left it for a little bit, which makes sense. But the original folks who were trying to build it, didn't have access to manufacturing, didn't have the connections to people to like diamond turn lenses, which would cost like $4,000 per lens. And even getting like displays or getting circuit boards made were something I had no idea how to do. Like I went to school for architecture for buildings. The whole reason I got into North Star was because I was really mad at Magic Leap at the time, because they had just launched the Magic Leap 1 and it was like $2,500. I was like, okay, that's reasonable. It's high tech, it's cool. And then they're like, oh, by the way, it doesn't work with glasses. And if you want glasses, you have to spend an additional $250 for these lens inserts. That's where I drew the line. I'm like, you know what? I'm going to build a headset for cheaper than the cost of your prescription insert. And I did. It was very janky. The first one I ended up building was I bought a Samsung Odyssey headset off of eBay. And then I disassembled the entire thing and rebuilt it into a North Star. And it took me months because no one else had disassembled this thing. So I'm like going in blind, I'm like prying stuff off, unscrewing things, figuring out, oh, the displays happen to be the right size and stuff. But it took quite a while. I would say this was about a year into it before we actually had connections with folks who were actually in China, who were actually able to get us in contact with people who were able to injection mold things and build circuit boards and stuff. And that's largely thanks to Noah Zirkin, who really took the project from 3D printed fantasy land to something that for a while you could actually buy kits for. And supply chain stuff this year sort of threw a wrench in that a little bit, but we're finally getting back on track to being essentially able to service DIY kits to folks who want to build their own.
I was going to say, the thing that makes this fascinating to me is it's an AR headset is a really complicated piece of hardware, right? There's the actual frame that you put on your head. Then there's optics, there's tracking of the world around you, there's tracking of the interface, whether it's hands or a controller or whatever. And then there's presumably some sort of software stack that can talk to a PC or a phone or some other host that is going to make the whole thing, like it's going to synergize all of these inputs together and give you an experience. So where did you even start with this, I guess?
Yeah, so I mean, that's a great question. I think realistically, one of the things I've been saying about AR is that it's just a puzzle. Right. And there are companies out there who are solving specific parts of the puzzle, but no one's selling the puzzle as a whole, except for like Microsoft and Magic Leap, maybe, who have sunk billions of dollars into this. Right. So one of the things we realized with North Star is like, okay, we're a relatively small community, right? Our Discord's like just over 2,000 folks. Not all of those folks are actually building their own headsets and stuff. There's a select group of people, there are dozens of us, who are actually like working on building either the hardware, software, all that stuff. And I think like Leap Motion provided a great base for like, okay, here's the optics and here's the hand tracking. And of course the hand tracking was their closed source thing. I think one of the really interesting things about North Star is, right, there's like open source where like everything's open source, and there's open source where parts are open source and things like that, or open source APIs and stuff. And North Star is generally open source to the point where if you wanted to take out a Leap Motion from the equation and put in your own hand tracking solution, like from MediaPipe from Google, for example, you can do that. No one will stop you, right? It's your headset, which is great. And for a while we've been, I think like the essence of it is that it has to be modular. And what we've done, we originally started with HTC Vive trackers on the headset itself for 6DoF, and that worked okay, but then you've got the lighthouses and stuff, so you're pretty limited. And we're like, okay, how do we do inside-out tracking, right? Which is like what the Quest has and all that. And we're like, well, doing that by ourselves is like PhD paper level stuff. And even those are like, you've got to compile like 18,000 Python libraries, and then maybe on one computer it'll run okay if you get lucky. So what we've been using for a while was the Intel RealSense T261 Center, which is a closed sourced 6DoF tracker. It essentially is a black box with cameras on it that output to pose. And we're like, this is acceptable for now. It was relatively low priced. It's discontinued now, which is a problem we're trying to resolve. And we've got some solutions on deck for it, which is exciting. But essentially, it's all about, okay, we've got this puzzle to solve. We've got parts of the solution. We've got the optics, we've got the hardware, we've got the displays. We've got relatively decent hand tracking from multiple solutions at this point. We've got the Leap Motion, which is still the best in the business. We've got MediaPipe, which is an open source one, not as good, but still works really well. And then we've been working really closely with an open source consultancy called Collabora, who have been doing their own open source runtime, which essentially is that glue we were talking about earlier, about how it's that layer between the hardware and then the application that actually reads in, like the headset pose, where you're actually looking, does all the perspective warping and all that fun stuff, renders, a window in 3D space. And those folks have been instrumentally helpful to us, not only in providing a fully open source stack for us to run off of on Linux, but also they've ended up hiring a few people from the North Star Discord, which has been incredible. There are a few folks, Moses Turner and my friend Charlton, who is starting there soon, who both spent a lot of time doing North Star stuff, either like trying to like hook trackers into Steam VR or create mathematical distortion projection for the actual optics, right? So to get a bit nerdy here, the way the optics work is that you've got a display sort of behind your left, like to the right of your eye or so, and it shoots parallel rays at a parabolic combiner, which is sort of the same shape that's used in like antenna dishes for like alien radio stuff, like typical satellite dish shape. And what it'll do is it'll take those parallel rays and essentially reflect them, and it'll point them all to the same spot, to a focal point, which is where your eye is. So it's a really, really simple mechanic. But one of the problems with parabolic reflections is you get distortion, right? You can see, like I'm showing right now on the video feed we have.
Yeah.
But essentially, if you just reflect an image, it's going to be upside down. It's also going to have like warping on it. So you have to do a lot of math to essentially resolve that image so it actually shows up properly to your brain, and you can see like, okay, now there's a cube in front of me and I can move around this cube and it's acting the same way that it does in real life, and it's actually straight edges and stuff. The thing I like about North Star the most is that it's taken those annoying word problems that you get in math class, like Tommy has 4 oranges and Sarah has 5 apples, like these improbable things that will never happen. And it gives you like a real world case to be like, okay, I've got a bunch of parallel light rays pointing into this geometric shape, and I need to get them to look correct. And all of a sudden, it's no longer theoretical. It's like, oh, this is a problem I can solve with Python. And like, this is really how I got into coding. I mentioned earlier, I went to school for architecture for buildings, and I started coding in Unreal Engine because I got tired of waiting for so in architecture, you have to render buildings, right? So you have to like submit them to the computer, it renders them, it like simulates all the photons, and you get like a really, really pretty picture after like 2 hours if you're on like a student laptop. Yeah. And I was like really bored one day, and I was like, okay, I'm gonna play some Minecraft to chill while I'm waiting for this to load. And I realized, video games are like 60 frames per second, and the image is pretty for each one of those frames. So I'm going to take my building and put it in a video game engine and then have it render instantly, and then I can go play games because my work is done. So I went from like doing Unreal Engine, which is like best in class visual scripting stuff, honestly, like that's how I learned. I didn't know what a vector was, so I'm like, oh, this yellow dot connects to this yellow dot. And then eventually I like brute forced my way into learning how to code. But after doing North Star for a while, I'm like, oh, I need to learn Python to do this thing, or I need to like use OpenCV or something. And it was just, again, like brute forcing through all of this stuff that you learn in computer science school.
Well, often the hardest part is learning what is the thing that you need to know, not how to do it, right? If you don't know what lens dewarping is called or whatever, whatever that.
Oh, yeah.
Yeah.
Can't solve a problem until you can name it.
Growing up, I was like used to being like one of the smartest people in a classroom or something. And then all of a sudden you're in this North Star Discord, and it's like, oh, there are like people who actually know how to do math in here. Or like, this guy just mentioned calculus. Okay.
The optics people, it turns out, are real good at math. Who knew?
Right. Oh, absolutely.
I wanted to touch on the early days of kind of prototyping the hardware that you touched on, or you mentioned, you described as janky earlier, and then since you were showing us the lenses just now, the thing you mentioned before we started recording here is that the first lens that you have was printed out of resin, which is something that I didn't even realize could be done. I was wondering, like, what are some other examples of just like scrappy kind of makeshift manufacturing techniques that you had to employ early on to get stuff going?
Absolutely. Yeah, I mean, for a while, we couldn't get displays. We couldn't get circuit boards to actually run those displays. So the first people in the world who had North Star outside of Leap Motion ended up using Raspberry Pi displays. And then they would take their 3D printed lenses, which is one of the parts I worked on very, very early on. And then they would tape reflective, like half mirror reflective tape on the insides. They would have like 3 ridges on the lenses from like where the adhesive was overlapping. And then they would take these like 3.5-inch Raspberry Pi displays that were like super cheap, but also super low res. And they would use those in place of the actual high resolution VR style displays that were spec'd by the project. And that was by a group called EXII, EXII, out of Japan. And they had this thing built like 2 days after the code dropped. Like it was insane. They moved so fast. And that was the sort of de facto stuff for a while, was either that or the project I was working on, which was like, oh, I'm going to take apart a headset that I bought off eBay and reassemble it, which took me like 3 tries before I was able to actually get it right.
That sounds expensive, Bryan.
If you buy ones with scratched lenses that you don't need, you can get them for like $100, but it was expensive. Like, luckily I had just gotten out of school and I was like, I don't have homework anymore. What am I supposed to do with all this time? And I'm like, headsets. That's what I'll do. You know, it worked out. I mean, it was also like a benefit. Like my work at the time had a 3D printer and no one was using it. So I sort of was like, hey, boss man, can I use this? And he's like, I don't care. Go for it. I had to like fix it up because it was like dry and like dusty and stuff. But once I got it working, it was just like off to the races at that point.
I think you mentioned early on that you ground those printed lenses by hand. Where did you learn to do that? I mean, was that something that came out of working with this open source stuff? Like,
yeah, so the original ones that were printed in resin, right? When you print in resin, it's like really clear until it dries and it becomes foggy. You'll have like surface imperfections and stuff. And there was like one other guy on the internet who like did a internship with Forum Labs, which is a company that makes resin printers. And he's like, oh yeah, I experimented with doing camera lenses out of resin. And here's the process I did. He did a process called resin dropping or resin dripping, where you essentially take the printed part and you put it into a vat of resin and let the resin sort of like fill in all the holes on the surface. I didn't have access to that because I was essentially ordering these from a printer, I think, I forget what
Pinocchio
company we ended up using. Yeah, like 3D Hubs, I think, was the one we were using at the time. And I was like, hey, I need these like printed. They were like, okay, but just so you know, they won't be optically clear. I'm like, that's fine. I'm just trying this thing out. So I get them and they're like really foggy. Even looking at them, there's like enough scratches on these, even the sanded ones that I did, where it still affects like text clarity and stuff, especially, these aren't even reflective, right? They're just resin. That was like the first step, was like getting the shape, you know?
Yeah.
I was like looking through this stuff and people were like, oh yeah, I used like this Novus polish cleaner on like headlights and that worked really well. So I bought like a bunch of that stuff and I was like sitting there in my backyard, just like sanding this thing for hours. And eventually it did get clearer, but it still had like surface imperfections and stuff. So at that point, we were really lucky and we finally were able to have person from Japan, from China, who was like interested in North Star and was like, oh, by the way, I just purchased an injection mold for these. I'm going to start selling them online. And that's where we start getting the first actually properly clear acrylic lenses, which was huge. I mean, it was just such a big jump in making this project actually feasible.
Bryan, what's your goal ultimately with Project North Star?
You know, that is a great question. And sometimes it escapes me. Sometimes I'm like, oh man, I'm really frustrated with this project. My 6th-off tracker disconnected again. And usually when that happens, it's because I haven't worn it in a while. And I'll like put it on and I'll open one of our demos and I'll like make something with it. Or I'll just like move around an object in 3D space and I'll be like, this is why I do this. Like anytime I put on the headset, I like feel re-energized about the whole project. It's like, yes, there is something magical here about being able to manipulate a digital world with my hands and have it like sit next to things on my desk. And then to also be thinking, I built this with my hands is just incredible. Like it is such a nice thing to be able to be like, I have this device, which very few people in the world have, that is special, unique, and comparable to these devices that folks are putting out from Microsoft or Magic Leap that literally spent billions of dollars investing in. And sure, we don't have the form factor that a Magic Leap 2 or a HoloLens or Snap Spectacles has. But the fact that the experience is still there is just really what matters to me. Being able to be okay, the functionality is roughly the same with these caveats. One thing we haven't touched on yet is spatial perception and being able to be oh yes, that's a table, that's a chair, this is a surface, this is a wall. Those kind of algorithms we don't have yet, right? We have pose estimation where we can move around objects, but it doesn't know, oh, there's a table here. One of the tricks we did early on was we would point our finger and just hold it on a table. And if we held it there for long enough, we would tell the computer, yes, there's a plane there. And then we could throw a ball and it would bounce off the table because we've artificially told it that there is a table. But it's convincing. And I think that's the kind of stuff that I'm really excited about is while we don't have fully one-to-one comparison with the big guns in this space, it's competitive enough and special enough to where you get enough presence and really feel like you are getting something out of the time you've spent with it.
That sounds great.
Yeah, I mean, democratizing this kind of hardware obviously is a pretty noble goal. I will also say, I think the one thing that you have that the big players don't is that this is probably one of the most cyberpunk concepts I've ever heard of. Just the idea, it genuinely feels like something.
Well, cyberpunk is interesting, but it also refers to dystopia, and I don't think that's what we're trying to shoot for. We want a protopia generally where folks are using AR or augmented reality or XR or whatever you want to call it for good, and that's part of the reason I work at Looking Glass as well, is because we generally have this vision of a positive future. And Keiichi Ban, who actually worked at Leap Motion on North Star before leaving to do other ventures, made out his Mirror Worlds video, which is just excellent. I'll send that over email later. But just being able to see and envision the bad people can do with it makes you want to have something that's under your control, right? The thing that terrifies me about this stuff is contact lens AR. I don't want that. That seems bad. No, thank you.
Well, wait, why not?
I don't want to put tech in my eyeball. That seems weird because it's one layer away from you cannot easily take this contact lens out of your eye. Right? It's a process. You've got to find a sink or whatever and then get it out there. But with the glasses or a headset, you can take it off. But once you start getting into the contact lens or bio stuff where it's close enough to where it's actually physically on you, I guess. I mean, contact lenses are interesting because they're not they're a level closer than glasses, right?
Right.
You and I, we are actually all wearing glasses here. We can just take our glasses off and now we're not wearing them anymore. And I think that's very important for the future of this product, right? We've seen how, this is going to get ranty, but we've seen how we can get glued to our phones. But at the end of the day, you can still turn your phone off. And my fear is that we'll end up in a world where it's glasses on all of the time. And I don't think that's where I want to go personally.
And there's also the concern that the vulnerability in your glasses suddenly becomes a way for somebody to murder you by software by just painting over the open manhole in the street, right?
Mm-hmm. Yeah, and the nice thing about North Star is it's a transparent optic system. So you can differentiate a virtual object from a real one, just in the fact that it's a little bit see-through. But that's going to change once, we're already seeing headsets that are video pass-through, the Lynx XR1, which is super exciting. Stan LaRoque and his team have been doing an amazing job there. But also the Oculus Quest pass-through stuff is all video pass-through, and the next one is going to be color pass-through. Right now it's just grayscale for Oculus. But when they release their next one, it's going to, you're seeing things overlaid onto a camera feed, which looks real, right? It's the Apple's AR kit kind of realism, which is very, very realistic. And that's that kind of stuff that's going to be really tricky. Is obviously you're still wearing a headset, but one day it's going to get to the point where it is a glasses form factor and you're going to not be able to tell the difference per se. But that's still very many years out, but is something that we'll probably hopefully still be thinking about with North Star at that point.
So if I wanted to build my own Project North Star headset, it seems like you have some older kits that we don't need to talk about anymore, and the thing to do is the Deck X right now, right?
Yeah, so the best place to start would be docs.projectnorthstar.org. Not projectnorthstar.org, docs.projectnorthstar.org. I haven't finished the main website yet. So just the docs subdomain.
But the docs are really good. I've been enjoying, I've been going through the docs for the last couple hours. There's a lot of cool stuff in there.
That was like my after work relief, was writing those documents. I was just like, I'm going to sit down and just explain things to people who are going to read this in the future. It's going to be great. And I spent, along with some other folks, we spent quite a lot of time building out those documents. You know, even like full picture by picture build guide, highlighting like all of the like little red circles where screws go and stuff. You know, in an ideal world, we want to get it to the point where it's more like a IKEA furniture, Lego kit kind of deal, where eventually you'll be able to snap things together. Right now, it still requires a bit of screws and electronics knowledge, which is fine because people can learn that.
Yeah.
Like I learned it. And if I can learn it, other people can, which is really exciting to see, like a little bit of a tangent incoming. But one of the things we don't really teach very well is like you can repair electronics. It's a thing that's possible. And like all of these things, like our phones, our laptops and stuff, all have circuit boards in them and they all do these things. They like seem super complicated. But the moment you start to decipher it, where you're like, okay, this is just sending 80 different signals to this display, or like this is doing that, and I can like generally understand like this stuff, or I can learn more about it because I know what to look for now. Like I know what a microcontroller is, for example. I think it's like really powerful. And I think that's one of the reasons I've kept doing North Star for all these years is like, I want it to be a gateway for folks to learn more about this hardware and electronics world that we live in. It's kind of like cars in a way. I'm not a car person. And if I open up an engine, I have no idea what I'm looking at, you know? With North Star, I at least see like with all this AR stuff having the potential to be like the future of computing, whatever that means. You know, I see it as like a way to sort of broaden the scope of microelectronics to something folks can actually build.
Well, you're investing in the future, right?
Yeah.
But okay, so to roll back, what's the level of expertise? Like, do you have to be a master solderer? Do you have to be able to 3D print things? Do you have to be able to design stuff and 3D print it? Or is it more accessible?
So for a while, we have an option where you're going to be able to buy the 3D print parts, which on its face seems a bit silly because the whole idea of 3D printing is like you learn how to do that. But some folks just don't have the capital to buy a 3D printer, right? You know, they're buying like this $500 to $600 headset, depending on what sensors they want in it. And they're like, okay, I have enough money for just this, and that's what I'm going to do, which is totally fine. And I think we're trying to be amenable to that. But as far as like skill set, general comfort level with electronics is nice. There's no soldering involved. We have a version of the 3D print, which uses these things called heat set inserts, where you can use a soldering iron to essentially melt this little metal piece into the plastic, which will allow you to thread screws better. But that's not required. You can actually, we have a version where you can just screw directly into the 3D print, which harms the life of the 3D print if you take it apart multiple times, because you're actually just destroying the plastic, but it does work. You can just print another one. Yeah, I would say in general, like if you've built a computer before and you're patient, you can probably build a North Star.
Huh. That's fascinating. Like conceptually, that's amazing to me.
Yeah. I mean, it's just at that level where it's not too small, where we would have to assemble things beforehand and then ship them out in like kits where you just put the housing around it. I think that's eventually what it will have to be if we want to stay, I'm going to air quote here and say competitive with the things coming out like Snapchat spectacles and all that.
Yeah.
There is a desire for a smaller form factor, which we're looking into, which would essentially use smaller displays and have a different optical system where you would magnify that small display and then point that to a bigger combiner of some kind. This is all still in like the phase of like we're sketching it out and have no idea what we're going to do because it all depends on availability of everything. And it's very difficult to do that right now, at least. So it's interesting because these other companies out there like Facebook and Microsoft are always planning for like 5 projects ahead. Like the Oculus Quest 5 is probably already in development somewhere in some secret lab. And, you know, we're like, okay, we're focusing on North Star version 1.5 essentially. And it's just had rolling updates. Like the general hardware, the displays and lenses have stayed the same with minor improvements to the optics over time. You know, the thing that's improving is the software. Like we went from the Vive tracker to the RealSense. Now, because the RealSense is out of is dead. What's the term for it?
End of life.
Is end of life. Yeah, I wanted to say dead, but that's mean.
Nope, they
it's
still
end
work.
Of life.
They're just not going to continue supporting or making them.
Yes. So we've been partnering with another company called Luxonis, who make generally open source stereo cameras called Depth AI. They've done a few Kickstarters for their system, and they've been amazing friends to us. Like I've literally called Brandon, their CEO, on Discord a few times, and he answers every time. He's like, "Hey, Bryan, what's up?" And we're like, "Oh, we want to chat about this new camera." And like he actually spends time listening to us. And we're like, "Okay, yeah, we can make that happen. Just order, we need to order some bulk amount of them for it to make sense for those folks." But in general, we're starting to gain more momentum with different allies in different areas, which is really nice. Like we've tried communicating with them in the past, and they've been amenable when we wanted to order like T261s or T265 sensors, which are the 6DOF ones, 6 degrees of freedom. So many acronyms.
Yeah.
I try to avoid that.
We'll cover that.
Yeah. There's a glossary on docs.projectnorthstar.org that covers a lot of these. That was something I'm actually pretty happy to have built because there are just so many acronyms everywhere in every different part of this project that just exist because it's an industry. But I think like it comes back to that original thought that I had about the puzzle, right? Is we're creating that glue that will hold the puzzle pieces together. With Collabora, with their open source runtime Monado, we're finally getting enough traction to where this thing's going to become an actual legitimate software competitor to a headset with a fully open source stack. Like fully open source hand tracking is on the way, fully open source 6 degrees of freedom tracking is on the way, and they're good. It's not like, oh, this is open source and it's really bad. It's like 3 years old. Like this stuff is actually competitive with the closed source solutions now, which is super exciting. And I think the benefit of Northstar is like, if you still want to use those closed source solutions, you can. There's a lot of like argument to be made about like, oh, is it fully open source? Is part of it open source? And I think like the general thing that brings and draws me to open source is the freedom that's involved with being able to make your own choices. If I'm a developer, I want to use the Leap Motion for hand tracking, I can do that. If I want to use Collabora's hand tracking, I can do that as well. And there are benefits and trade-offs to both of those. But at the end of the day, it's what you want your headset to be, which is really exciting.
If I want to build a headset, I know that with this kind of project especially, there are runs, right, where there's parts available for a while, and there's parts that aren't available, and there's parts that are available and they're not available. But is anybody assembling like the equivalent of a 3D printer hardware burrito, where it's like, hey, here's all of the stuff, here's all of the metal stuff and all of the circuits and all of that stuff you need, and then you can just take your 3D printed stuff and build your padding and whatever and assemble those yourselves and then put it together?
Yeah, so we've had that for a while. The supply chain really killed that, and we had to switch suppliers and everything. We're finally getting that back up and running. We're essentially building our own shop this time, handling it with one of our partners in Canada, Ahead.io. They're what are they? They do so many things. They build like robotics and also do like VFX stuff for like different cameras and lighting scenarios. And they're just like, we like Northstar. And I'm like, we like you guys. And they've been super helpful in helping us procure parts and bulk orders and everything. So we're working with them to essentially get a new proper storefront up for Northstar.
Oh, awesome.
And get kits available again. It has been, I would say, around maybe 9 months since we've been able to sell proper kits. A lot of that was because for a while, that chip I mentioned earlier, the Analogic 7530, went missing. It just like completely dried up. We've been able to source them again now, which is nice. So we're making headway there. And we've got about, I would say, stock of like 100 to 200 pieces currently of the full kits that we're working on getting actually packaged and sorted and ready for folks to buy, which is super, super exciting. It's been so long since I've been able to like walk people through how to build it again. Like that was one of my favorite things, was like people would just show up on Discord and be like, hey, I've got this kit. How do I assemble this part?
What's the experience when I'm putting the headset on? What's the experience like? What do I see?
So right now, nothing, because you haven't plugged it in yet, right? So essentially, it's not like a Quest where it'll automatically turn on and have compute built in and stuff. We do have some prototypes that use like a tiny like 4-inch by 4-inch motherboard from like AMD for their embedded stuff that works pretty well, and you can like clip that to your belt. You have to sort of have an app running. We have some like pretty cyberpunk style rigs that you essentially have like the keyboard on your arm where you can like input to the keyboard. You just see your screen like upside down. And then once you launch an app that actually is built properly, it'll just open in full screen and you'll have this virtual world in front of you. And sort of the default app we've been using is a painting demo where you can actually do finger painting by doing a little pinch gesture with your fingers and like choose different palettes and stuff. That's been really, really fun to demo to people. Because they're like, oh, I can make something. This is excellent. It just gives them that little bit of agency over it where like, okay, I get it. This is fun.
At that point, are you working in a 3D world or is it a 2D world for the...
Oh, it's all 3D.
Okay.
Even if you have a 2D window, it's in a 3D world, right? Because you want this stuff to move around with you. Like when it bugs out, because it does, like especially with the Intel sensor, sometimes we'll just like stop working. We'll be like, oh, I got to restart it. One of the things we actually did was we built another circuit board on top of the display driver board that just handles USB for like delete motion and for the RealSense. And we added 2 buttons to the top of the headset so you can reset the RealSense controller because it would just disconnect all the time. And we're like, oh, let's fix this with hardware. And the moments it doesn't work, it just feels so less real because all of a sudden you have this painting and it's just moving with you. It's like stuck to you. It like really just emphasizes how much the tracking component of it matters, even if it's not perfect tracking. Just the fact that you can move and this object stays relatively in the same space as you move is such a key to immersion, even beyond optics and everything.
The first time I tried HoloLens, we had this demo and we placed an object on a pedestal and then they had us walk out of the room and walk around a hallway with the headset on and come back and put some windows up. And when we came back, the object's still on the pedestal where we went. Like it literally felt like magic. It was a really, I was like, oh, okay, I get why this is interesting now. This is making the stuff that's computing feel like it's anchored in the real world in a way that your window on your laptop screen never does. So I totally get that. What do you use for controls? Is it all hands? Or you said you had keyboards you can strap on?
Right now it's all hands.
Okay.
Yeah, so people are doing like keyboards and stuff. Controllers are like a whole other ballgame we haven't even touched yet. We could do it. It's just a matter of like, okay, now we're tracking the headset. We're going to have the cameras on the headsets. Now we need to take the camera position of the headset and then figure out relative to those cameras where the controllers are. And it's like a whole really complicated ballgame that we have not decided to touch yet because the hand tracking works well enough for what we've been doing. One of my goals for a while was to get Beat Saber running on it. That does require controllers. You cannot Beat Saber with your hands. I have tried. It's not fun. I think like having it be focused, at least like someone eventually will want controllers with this thing and they'll do it and they'll figure it out. We have not yet met that person though. So if anyone's listening to this podcast is like, hey, I want to do controllers. People have done like fiducials and stuff with like the little like QR code, Eruco markers and all that, which do work, but we don't yet have full like 6 degrees of freedom Quest quality controllers. They paid a lot of money for that tracking software.
Look, those 3D
have a lot of money.
The molds for that stuff are crazy expensive. You can tell just by looking at it.
Yeah. Oh, we would 3D print it, and we would tape LEDs to it and stuff. But I think once you start doing that, it's like one of the things I haven't mentioned yet is calibrating this stuff, right? Because it's DIY, there are like little differences between every single headset that you sort of have to compensate for. And we've built essentially calibration pipelines where you stick this headset on a rig that has stereo cameras where your eyes should be, and then you run a bunch of OpenCV through it where you can actually read the reflection on the lenses and use that pattern to essentially figure out like the optical distortion or where the screens are relative to the optics. And then that's not only half the battle, because then you've also got to key it in for your interpupillary distance, right? Or how far away your eyes are, because that'll change how your eyes are actually perceiving the 3D image. And we've just started cracking the eye position game, where we have tiny cameras on the inside lid of the headset that are pointing down to your eyes, so we can figure out, okay, where is this user's eyes at, so they can put on the headset and then immediately have it look correct for them.
Wow.
We're not really interested in eye tracking. You could use them for that, but for our SDK, we're like generally privacy conscious and think eye tracking is creepy. So we're literally only outputting the position of the eyeball itself rather than where this user's actually looking at.
It seems like eye tracking is more useful for VR, where you're interested in like applying all the horsepower to like the center fovea area of your eyes perception.
Absolutely. And I think North Star has effectively the same resolution as VR. Like it actually uses the same displays as the Valve Index, which is neat. So it could be useful for that. It's just not a focus of, I guess, the community right now. I know it seems like cheesy to say that, but it is just a bunch of folks working on, like very few people are working on this as their actual job. A lot of folks are just contributing to it over time.
Well, with the difference in the 3D printed parts and the difference in the other headset pieces and the human differences in like interpupillary distance and eye position and all that kind of thing, I can only imagine the ergonomics of the head being a big factor. Mm-hmm. Maybe it's kind of simple, but probably actually not in reality when you get down into it, because there's a bazillion different head sizes and
So, ergonomics has been one of the biggest challenges with North Star. I think it has its benefits in that North Star is modular, so you can really change it based on the human, which is great compared to other things that would be typically injection molded and more closed source. There's a widespread difference in humanity, right? Like every human's slightly unique from the next one, and every human has a different head shape, roughly, right? So like the slopes of foreheads are different, or the way people's noses look are different. And
the distance between your eyes is different, wildly different based on like gender and age and all sorts of stuff.
Absolutely. Yeah, like it varies from like 56 millimeters to 72 millimeters. And I know that off the top of my head. But that's just based off of a Wikipedia article written in 1996, based off of a scientific paper. So maybe that's not the most accurate measurement anymore, but it'll do. The general thing with North Star is like, we haven't solved it. It is really has to be custom per person, we've found, which is fine because every headset is custom per builder. But as we move forward into some eventual land where North Star is like a thing you can buy one day, we'll definitely want to have multiple solutions for folks to be able to build, or maybe we even ship them with the headset. I think we can get them to the point where it's like, okay, you've got multiple headgear things you can put on the headset to have a better experience.
That makes sense. What's the software side of this look like, Bryan? Like, are you using Steam VR or OpenXR or
Sure.
WebV? Like, what are the APIs? If I want to build something for this, what are the web APIs?
Yeah. Oh, there's so many. So we have a Steam VR driver. It's really difficult to work with because Steam VR is closed sourced, and it's been really difficult for us to make. It does function, but it's not our recommended way of using it. So right now we sort of have a split stack on Windows and Linux. For Windows, we have a library that one of our Australian devs made named Esky. So in Windows, we have that, which plugs into Unity and Unreal Engine. Essentially, it handles all the low-level stuff, like it connects it does like the display reprojection, it does the 6 degrees of freedom pose integration, and sends that either to Unity or Unreal Engine. It's pretty lightweight, which is nice. And then on Linux, so Esky's not OpenXR, it's sort of its own thing that exists just to make North Star development faster. Then on Linux, we have Monado, which is Collabora's open source OpenXR runtime. And that has a North Star driver for it. So the idea behind Monado is it's this library that you can use with any headset that you were able to reverse engineer or put into Linux and stuff. So you can use it with the Valve Index, you can use it with HTC Vive, Oculus, Rift, all these other things, and you can use it with North Star. So it works similarly to Esky. It's like a lower level API that handles the tracking input, the headset reprojection, all that kind of stuff, the optics distortion, and interfaces with anything that can run OpenXR, which right now is Blender, Unreal Engine. Unity is starting to support it. We haven't tested Unity on Linux yet. And our go-to favorite on Linux right now is a library made by Nick Kliggensmith called StereoKit. Nick works for Microsoft and essentially built this really tiny OpenXR 3D library that is really fast to work with. It's really lightweight, really clean, and it's just been really fun for us to iterate with. Because the last thing we want is something that, like the bigger engines, like Unreal or Unity, have their focus on Windows, and that's just what it is because there's more folks there. And StereoKit is light enough to where there's a lot less that can go wrong on Linux because it's just smaller. So we've been using that quite a lot to prototype on Linux. But it really depends on what you want to use. If you want to use one of the big engines, I would still recommend Windows. And we support Unity and Unreal on that front. If you want to use something a bit more bespoke, definitely try out our Linux stuff.
Cool.
So do you expect the platform to remain open going forward? I mean, OpenXR is from the Kronos group, which is, people may know OpenGL and Vulkan as graphics standards from the kind of same consortium. But like early on in the graphics wars, you have like Microsoft coming in with their proprietary DirectX stuff. Do you see any corporations trying to like muscle in or shoulder their way?
Everyone's on board with OpenXR because the problem is the market's not big enough for them to do their own thing. If they do their own thing, they're going to die. That's just how it is at this point. With OpenXR, you also get access to WebXR, which is huge and super, super exciting. So WebXR is the web's API for XR devices, which hooks into OpenXR, which is the hardware interface for hardware. So it goes hardware, OpenXR, browser, WebXR, or WebXR browser, I guess. But it's, no, I think open standards are here to stay, especially for this industry. We're working on getting, and I say we, mostly Collabora is working on the Monado runtime, which can compile on Windows now, which is super exciting. So there are milestones being hit there. So eventually the idea will be that we'll have one runtime across platform that'll be OpenXR compliant, that'll run on both Windows and Linux. There will be limitations because there are things you can do on Linux that you can't do on Windows with regards to like device override and stuff. So that very first headset I built, the one that was a Windows mixed reality headset at one point, will only work on Linux because on Windows you cannot override the device driver. But on Linux I can be like, yes, this is a North Star. And Linux will be like, sure. Windows will be like, no, I don't believe you.
That's funny.
So yeah, I think open source, especially for the standards, are absolutely here to stay. No question about it.
I wanted to ask about working in open source hardware conceptually. I mean, open source software development is robust and thriving in a way that's very well documented. But for open source hardware, is it more of a niche scene or is it harder?
Very tricky.
Right, because you've got access to fabrication equipment and physical distribution of goods and all these other limiting factors.
Yeah. So like the fabrication, honestly, it's difficult, but we can get it done, right? There are professionals we know. We can send it to those folks and they'll build it. The problem is actually open sourcing the hardware because every chip has its own firmware. Like for the North Star, to get like super technical here, we are using a Analogic 7530 DisplayPort to MIPI adapter. So to describe what that is in normal people speak, essentially you need when you send a signal to a computer, it typically is DisplayPort, HDMI or whatever, and you plug that into the driver board. The driver board then has to convert that signal to the actual signal the displays themselves take, which isn't DisplayPort. It's actually a different format called MIPI, which I forget what it stands for, but it's an industry standard for display connections, which are these tiny little ribbon connectors. Essentially, so we're using that chip in our driver board, and a lot of companies get really cagey when you start talking about open sourcing firmware for stuff, because that's their closed source thing. So luckily for us, Leap Motion did handle most of that before we started the project, and we're able to open source the firmware for it. So we didn't have to deal with just figuring out the logistics of that. But it can get really tricky when you start doing that stuff. Other companies that are sort of doing open source firmware, which is very rare, like Framework, the modular laptop company, just, I think recently, open sourced their firmware at least part of the way. They have enough capital and momentum to actually make those moves, which is really exciting. I think one of the problems we've had with North Star is we're still small. Folks are like, oh, do you have a $300,000 to order 4,000 of these parts? And we're like, not really. Can we order 500 and we'll make it work through that? And we've been able to do that, but it's definitely really tricky to not only design open source hardware, but then make sure it's properly open source, make sure you're not accidentally leaking NDA stuff, because every chip has an NDA spec list and all that. The displays we use technically, I can't share the data sheet with you because it's under NDA with the company who makes it, which is BOE. So there are aspects of that where it's there's just stuff that is closed source that you have to deal with.
Thanks so much, Bryan, for coming by. This has been a fascinating conversation. I'm really excited about the future of the headset, and I can't wait to see what happens next. I'm going to be watching for the next drop to see if I can put together maybe a kit of my own to try it out. I want to see what this looks like when you put the headset on.
It's cool as hell to me. I mean, there are still some barriers to entry. You do need to get some stuff 3D printed. You got to get the lenses. It's not necessarily the cheapest prospect yet, but it's still,
AR isn't the cheapest prospect yet.
Right. That's what I mean. It's still a step in the right direction, right? Because previously, like he said, this was the domain of Microsoft and Magic Leap, and gigantic corporations. So even though it's not ready to just, well, they do sell kits. Like they're getting to that point that it's kind of becoming available for everybody in a much more open and extensible way.
And the other interesting part of it that we talked about a little bit is the kind of ergonomic / accessibility side, which we realized early on in the VR days. If you build a headset that fits 90% of humanity, it turns out 10% of humanity is A, large number of people, but B, impacts people of different genders, and it's a really complicated topic. And even things like not fitting eyeglasses under the headset, like we talked about, it sucks. It's a bad choice. So being able to customize your hardware for you is really interesting to me as somebody who's been building computers now for 25 years, I guess. So I guess that's the show for this bi-weekly period.
Mm-hmm.
As always, special thank you to Google Open Source. They bring all the value of open source to Google and all the resources of Google to open source. You can find out more at opensource.google. The FOSSPod is edited by Sabrina Hill and I guess produced by Brad and me.
Us for now.
Yeah, I'm Will. He's Brad.
Mm-hmm. That's me. You're you.
We will be back in about 2 weeks with another episode of the show. Thank you all so much for listening. Welcome to the FOSSPod. I'm Will.
I'm Brad.
I feel like I put the accent on the wrong syllable there.
That's not how you... None of this is working.
I put the accent on the wrong syllable?
Tongue, mouth, not, go...
Okay.
Work
Try
good.
again.